Dear students and viewers, you are most welcome to this discussion on time value of money. Although this particular topic is related to your financial management course covering lecture 3 and 4, but this particular concept is widely used and is very relevant to the business education. In this discussion, I am going to cover the topics like time preference of money, simple interest and compound interest, future value and present value of lump sum, future value and present value of annuity. If we think in a rational way, all of us have time preference of money. That means we like to receive cash at now instead of receiving the same amount of cash in future time. Just consider these two options. Option 1 to receive taka 1000 now, or option 2 to receive taka 1000 after 1 year from now. Rationally, anyone will select option 1 to receive taka 1000 now, but the question is why? This is because of current consumption is preferred as compared to the future consumption. There is uncertainty about future, we do not know what will happen in future. We have investment opportunity, because if we invest money at now, it will grow in future, and due to inflation it will reduce the purchasing power in future. If in option 2 taka 1000 is changed by taka 1090, then the difference between future amount and the present amount will be taka 90. This is called compensation or interest for waiting 1 year. There are two types of interest. One is simple interest and another one is compound interest. Now, it is clear that we like to receive cash at now. Otherwise, we can ignore the current receipt of cash taka 1000 if we have another option to receive little more money in future. For example, the amount of simple interest depends on 3 variables: the original or principal amount P0, the interest rate per time period I, and the number of time periods n for which the principal is borrowed or lent. We can use the formula for calculating simple interest, which is SI is equal to P0 means principal amount, I means interest rate, and N means number of time periods. At first, we can discuss about simple interest. Simple interest is the interest which is calculated only on the original amount of investment, which is called principal. Now, for example, if you want to deposit taka 1000 in a savings account which is paying 8% simple interest per year, and if you want to keep it for 10 years, you may be wanted to calculate the total amount of simple interest. We can use a formula to calculate the total amount of simple interest. In the formula to calculate simple interest, we have P0 or initial investment taka 1000, I or interest rate 8%, and number of period 10 years. Now, by putting these values in the equation, we are going to calculate simple interest, which will be taka 800. This taka 800 is the total amount of simple interest only. Now, if you add the principal amount of investment with this interest, then you will get the total lump sum amount of investment at the end of 10th year. This is called the future value or terminal value. Future value is equal to principal plus interest, that means P0 plus SI. Now, we can break down SI, so it will be P0 plus P0 into I into N, and by taking P0 as common, the formula will be P0 into 1 plus I into n. This is the formula to calculate future value under simple interest method. Now, by putting the value in the equation, that means present value 1000, interest rate 8% and n is 10 years, we will get the future value and that will be taka 1800. That means your investment of taka 1000 will be taka 1800 after 10 years at 8% simple interest. Sometimes we have to think in opposite direction. Suppose you want to deposit some money at now at 8% simple interest to receive taka 3600 after 10 years. Now, the question is how much money you have to invest at now. Here we know the future value which is taka 3600, simple interest which is 8%, but we have to calculate the original investment or principal amount. This is called present value. If we rearrange the formula of future value, we can find the formula to calculate present value. In this formula to calculate future value, we can interchange left hand sides and right hand sides. Now, if we want to calculate present value, we will keep only P0 in the left hand side and in the right hand side future value will be divided by 1 plus I into n. This P0 is also called present value at now. Now, we can use this formula to calculate present value and we can put the values because future value is 3600 divided by 1 plus interest rate 0.08 and number of period 10 and we will get the present value that will be taka 2000. So far I have discussed about the calculation of present value and future value under simple interest method. However, practically in business we use compound interest. Let us know about compound interest. Compound interest is calculated on the principal amount as well as on the interest earned in the previous periods. The formula for calculating compound interest is Ci is equal to P0 into 1 plus I to the power n minus P0. And this first part, that means P0 into 1 plus I to the power n, is also called the total amount of principal and interest at the end of n periods. Just recall, simple interest is calculated on principal amount only, whereas compound interest is calculated on principal amount as well as any interest earned in previous periods. Now, we are going to solve a problem to calculate future value under compound interest. Using formula for future value under compound interest, we can calculate future value after 1 year FB1, that will be P0 plus P0 into I and it will be P0 into 1 plus I. So, the future value after 1 year will be used in the second year to charge interest under compound interest method and it will be P0 into 1 plus I square. Look, for future value after 2 years it will be P0 into 1 plus I square. Similarly, to calculate future value after n year it will be P0 into 1 plus I to the power n. So, these two numbers will be the same. So, this is the formula to calculate future value under compound interest method. Now, if we invest taka 1000 for 10 years at 8% interest rate, then we can calculate future value by putting the values in the formula. So, future value at after 10 years will be 1000 into 1 plus 0.08 to the power 10 and the amount will be taka 2158.9. So, the future value will be taka 2158.90 after 10 years if it is compounding annually at 8%. You have to use scientific calculator and formula to calculate this future value. Instead of using formula or scientific calculator, you can use table to find the future value interest factor. Now, we are going to discuss about the use of table to find future value interest factor. The formula to calculate future value after n period will be P0 into 1 plus I to the power n and it can be written as P0 into future value interest factor with I interest and n periods. So, 1 plus I to the power n is termed as future value interest factor with I interest and n period. We can find this number by using future value interest factor table. If I is equal to 8% and n is equal to 10 years, then we can look at the future value interest factor table, where we have to move to the right side horizontally to get 8% interest rate, and we have to move downward vertically to get number of period, that is 10. So, by matching this column and row, we will find the future value interest factor for 8% and 10 years, that will be 2.15890. If you carefully look at the formula to calculate future value of a lump sum amount, we can rearrange this particular formula to get the formula for calculating present value of any lump sum amount to be received in future. In the formula to calculate future value, if we interchange left hand side and right hand side, then we will get the equation like P0 into 1 plus I to the power n is equal to Fp. Now, if we keep P0 in the left hand side, then the equation will be Fp divided by 1 plus I to the power n. This P0 is called present value at 0 time. Now, this formula can be rearranged in this way, where the second part is called present value interest factor. We realize that a taka today is worth more than a taka to be received after 1, 2, 3 years or in future. Suppose you have two options, either to receive taka 1000 at now or to receive taka 2000 after 10 years. Let us assume that both sums are certain and your opportunity cost is 8%. That means you can either borrow or lend money at 8%. To take your decision in this particular case, you have to calculate the present value of taka 2000 to be received after 10 years, and you have to compare this present value and taka 1000 to be received at now to get your conclusion. To calculate present value under compound interest, we can use this formula now. If we want to calculate the present value of taka 2000 that will be received after 10 years at 8% rate, where future value after 10 years is taka 2000, I or interest rate is 8%, that is also called discounting rate to calculate present value, and n is 10 years. Now, putting the value in the formula, we will get present value that will be taka 926. Just look at the second part of the formula. This is called present value interest factor with interest rate I and n periods. So, you will find this number in the present value interest factor table. Here the result 926 is less than taka 1000, which can be received at now. So, we can arrive at a solution that instead of receiving taka 2000 after 10 years, it is better, it is wise to receive taka 1000 at now, because the present value of taka 2000 is 926, which is less than taka 1000. So far we have discussed about the calculation of present value and future value of a lump sum amount or single amount. When we are going to calculate present value, it is generally called discounting, and when we are going to calculate future value, it is generally called compounding. Now, if you received or pay a certain amount at regular interval, then in what way you can calculate the present value or future value? To know this thing, at first you should have the concept of annuity. We are going to discuss about annuity now. An annuity is a series of equal receipts or payments occurring over a specified number of periods. There are two types of annuity: ordinary annuity and annuity due. In case of ordinary annuity, payments or receipts occur at the end of each period. In case of annuity due, payments or receipts occur at the beginning of each period. In order to calculate the present value and future value of an annuity, we will consider compound interest only, not the simple interest. In our practical life, many times we use the concept of annuity. Many of us has DPS in bank and we have to pay in every month a certain amount for DPS. Maybe you are interested to know from the bank how much money you will receive after a certain period. That means you want to know about the future value of the annuity. In the timeline up to 5 years, if you deposit taka 1000 at the end of 1 year, to calculate future value after 5 years, this money is compounding for 4 years only. So, the money to be deposited after second year, it is compounding for 3 years up to 5 years. Then the money to be deposited after 3 years, it is compounding for 2 years. Money deposited after 4 years, it will be compounding for 1 year, and the money deposited at the end of 5th year, there will be no compounding, because you want to calculate future value at the end of 5th year. Now, if this money is compounding annually at 8%, we can use the formula to calculate future value of ordinary annuity, where R is equal to the money you are depositing in at the end of each year. So, it will be 1000, and the future value annuity factor I is equal to 8% and n is equal to 5, that means for 5 years. So, we will get the future value of ordinary annuity, that will be taka 5866.60. Now, in the second part of the formula, this is also called future value interest factor of ordinary annuity, and you can directly get this number from table of future value interest factor of ordinary annuity. Now, if you plan to deposit at the beginning of each year instead of at the end of each year, and if you want to calculate the future value after 5 years, then you have to use the formula to calculate the future value of annuity due. Let us solve this particular problem and look at the screen. Now, in the time frame, if you deposit money at the beginning of each year and you want to calculate future value at the end of 5th year, then the first money is compounding for 5 years. The second money, that is you are going to deposit at the beginning of second year, that means at the end of first year, that is going to be compounding for 4 years, and the money you are going to deposit at the beginning of third year, that is compounding for 3 years. Money you are depositing at the beginning of 4th year, that is compounding for 2 years, and the money you are depositing at the beginning of 5th year, that is compounding for only 1 year. Now, the money is compounding here annually at 8%, and again we can use the formula. In this formula, this is the additional one, because all the money are compounding here for additional 1 more year. In the formula, the R, the money you are depositing in each installment, that will be taka 1000, and the compounding interest rate I is equal to 0.08, and number of periods n is equal to 5. So, the future value of annuity due will be taka 6335.90. Again, the second part of the formula, this is called future value interest factor of annuity due, and you can directly get this number from the table of future value annuity factor of annuity due. We have calculated the future value of ordinary annuity and annuity due. In other ways, if you plan to receive taka 1000 at the end of each year for next 5 years, then how much money you have to deposit at now in the bank. In that case, you have to calculate the present value. That means as you are depositing money at the end of each year, it will be ordinary annuity, and we are going to calculate the present value of ordinary annuity. Now we are going to calculate present value of ordinary annuity in the time frame of 5 years. The money that will be received at the end of first year, to calculate present value at 0 time, this money is discounting for 1 year. The money to be received at the end of second year, that is discounting for 2 years. The money to be received at the end of third year, that is discounting for 3 years. Similarly, the money to be received at the end of fourth year, that is also discounting for 4 years, and the money to be received at the end of fifth year, that is discounting for 5 years. Now we are going to use the formula to calculate present value of ordinary annuity, where R is the amount you are expecting to receive at the end of each year and discounting annually at 8%. So we are going to use this R is equal to 1000 and discounting rate 8%, that means 0.08, and number of period, that is n, is equal to 5. So we are going to receive, we have calculated here the present value of ordinary annuity, that is 3992.70. In the second part of the formula, it is called present value interest factor of ordinary annuity, and you can directly get this number from the present value of ordinary annuity table. However, if you plan to receive taka 1000 at the beginning of each year instead of at the end of each year for the next 5 years, then it will be annuity due. Now we are going to calculate the present value of annuity due. Again, in the timeline of 5 years, we are going to receive money at the beginning of each year. So at the beginning of the first year, we are going to receive taka 1000, and we are going to calculate present value at 0 time. So there will be no discounting of this money. But at the beginning of the second year, we are going to receive taka 1000, and that is discounting for 1 year. Similarly, at the beginning of third year, the amount to be received is taka 1000, that is discounting for 2 years. At the beginning of fourth year, amount to be received 1000, that is discounting for 3 years. At the beginning of fifth year, another 1000 taka will be received, and that is discounting for 4 years. We are again going to use the formula to calculate present value of ordinary annuity, where this term is additional as compared to the other previous formula. Now we are going to discount the cash flow at 8% interest rate, where R is the amount we are going to receive, that is 1000, and in the formula the interest rate 8% is used, that is 0.08, and number of period, that is n, is equal to 5. So the present value of annuity due is 4312.10, and already you have known that the second part of the formula, this is called present value interest factor of annuity due, and you can directly get this number from the table. Dear students, in this discussion we have learned about simple interest, compound interest, and the calculation of present value, future value of lump sum amount and annuity. I hope that this particular discussion will help you to understand the topics while reading your course materials. All the best to you, and thank you.